All right, good morning. Today is May the 10th, 2013. I would like for you guys to get the do now started. I want you to take 7 minutes to do that. So after you get the do now started, I like for this video to be paused because after this, I'm going to give the answers to it. The do now is on page 357. You're going to do numbers 1 through 8 and number 13. 1 through 8 and number 13. Please pause the video. Alright, hopefully the video was paused. So you were supposed to do page 357 for your do now. Alright, so the answer to number 1 is 2 to the 5th power. The answer to number 2, 3 to the what power? Alright, the 4th. Answer to number 3, 5 to the right, the 2nd power. The answer to number, sorry, that was number 3. The answer to number 4 is x to the 3rd power. What about number 5? It's kind of blurry. All right, number 5 is a to the 6th power. Number 6 is x squared y to the 3rd. So I want to make sure that you all are clear on how that looks. We got x squared y to the 3rd. All right, number 7 is 1/2 to the 1, 2, 3, 4, 5. So that's the entire 1/2 in parentheses to the 5th power. Yes, we should write the parentheses there. All right, let's take a look at this next one. That was kind of crazy, but we can see that these A's are on top. Ooh, let's get some clarity here. A's are on top, and we have 2 of them. We have 4 C's on the top, 2 B's, and 4 D's. So that's going to be a squared c to the 4th over b squared d to the 4th power. All right, and last but not least, I told you to do number 13, which was 2 to the 3rd power, all of it raised to the 4th. So this would technically be 2 thirds times 2 thirds times 2 thirds times 2 thirds. So you could look at it that way, or you could have looked at it as 2 to the 4th over 3 to the 4th. So 2 times 2 times 2 times 2 will give us 16. 3 times 3 times 3 times 3 will give us 81. So your answer should have been 16. I don't know why it's not coming out clear, but it should have been 16 over 81. All right, moving on. So we just finished our test, and unfortunately I don't have the papers to you today because I had to take them with me. But the grades should be at this point posted. Today I'm doing this. This is May 9th, but I should be able to post it by Saturday. All right. So we're going to talk about a couple of things. Let's call this multiplying monomials, and then we're gonna also divide some monomials as well today if we have time. All right, so let's get to it. All right, so let's title this multiplying monomials. The first question I would want to know is, what in the world is a monomial? All right, so that's the first thing that we're going to do. We're going to define what that is. All right, so a monomial is a number variable or a product of numbers and variables. All right, notice it said a number, variable, or product of numbers and variables. Excuse me 1 second. All right, I did not say sum. I did not say difference or division or dividing or quotient. So we have to be careful with that. So I'm going to give you what that's going to look like. Just give me a second to get this together. All right. So this is what a monomial could look like. 3, 3x squared, 4, or let's do negative 4, x to the third, y. These are all examples of monomials. This is also a monomial, 1 over 4x squared, because this is still a number multiplied by a variable. However, this is not a monomial. So we'll put a slash to that. Not a monomial. All right. So monomials are connected. Either they're alone like this or they're connected by the operation of multiplication. So you need to be able to do that first. All right, so way back when we did some work on exponents and negative exponents and all of that. That was like way back in the beginning of the school year. So we're gonna touch on that in this whole monomial business, but we have to make sure that we don't confuse stuff. So let's just go through a couple of things. Just give me 1 second to erase. The screen is not black. I'm just erasing a couple of things. All right. All right. So let's just recap on exponents. All right. So let's say for instance we had a to the 4th times a to the 5th power. This expanded would be a with dots in between. That's the 4th power. And the other one would be a. So if we had to scrunch it all in, we would do a to the 9th power. And so the rule says when you are multiplying numbers with the same base, all you do is add the exponents. So that's all you have to do in this case. All right, so here's the rule, and we're gonna write it out just in case we don't remember it. When multiplying, keep the base and add the exponents. Just want to make sure we remember that. So here's the rule. The base is the same, so it'll be a to the 4 plus 5 power. So that's going to be equal to a to the 9th. That works for any integers that have the same base and any letters that have the same base. All right, let's look at another example. A to the third, y to the fourth, all of this times a times y to the fifth. Notice you have a base of a here and a base of a here. So this is technically a to the 3 plus 1 power. Because remember, the understood exponent here is a 1. And then we have y to the fourth times y to the fifth. So that would be technically y to the 4 plus 5 power. So if you did it out, you will have a to the fourth, y to the ninth. All right, let's look at one more example and get off of this. All right, so let's say if we had 4a, that red doesn't work good. I'm gonna go to black. Let's say we have 4a b to the 6 times negative 7a squared b to the third. Now, if that's a lot going on for you, you can rearrange, because if you remember, multiplication is commutative. So we can multiply this 4 times this negative 7. So I can rearrange it to 4 times negative 7. And then we have the a here and the other a squared here. So that's a to the 1 plus 2 power. Then we have b to the 6 plus 3 power. B to the 6 plus 3 power. Change colors again, maybe that'll work. Alright, so 4 times negative 7 will give us negative 28. This will be a to the third and b to the ninth. Many of us could have probably did that in our head. 4 times negative 7 gives us negative 28. A to the first times a to the second is a to the third. B to the 6 times b to the third is b to the ninth. So that is all that you have to do in that case. The only other problem that they may throw you is when they have an exponent that's just chilling on the outside of a parentheses. So I want you to see that, and then we'll end with that. All right. So we have 3 squared. All of this raised to the third power. What you can't do is just say 3 to the fifth, because this 3 doesn't have like just another 3 as its base. So what this says is I want to see everything in parentheses 3 times. So in parentheses we have 3 squared. So that's 3 squared times 3 squared times 3 squared. So these are the same base. When you have the same base, you add the exponent. So what's 2 plus 2 plus 2? That is 6. So now you can see why I said you couldn't just add those exponents. But here is the shortcut. When there's an exponent that's just chilling on the outside, we could just treat it like the distributive property and just multiply. All right, let's do one more example like this and be done. What if you had 3x, y to the fourth, all of that raised to the second power? You have to think about it. This 2 has to be distributed to every exponent. So you say, hey, Ms. Nelson, everything doesn't have an exponent. But technically it does. This 3's exponent is really a 1. This x exponent is also a 1. And this y has an exponent of 4. So we're going to raise it all to the second power. And we're going to do it the shortcut way, because I don't want to write all of this out twice. So it's going to be this times this times this, and this times this. So 3 to the 1 times 2 power. That is 3 squared. X to the 1 times 2 power. That is x squared. And y to the 4 times 2 power. That is y to the 8th. So this is the final answer. As a recap, what we discovered today is that when you multiply numbers with the same base, you add the exponents. That's the only time that occurs. When you have an exponent that's chilling on the outside like this, then we distribute the exponent to each exponent within the parentheses. We also learned that monomials are connected through multiplication. They are not connected through division, addition, division, or subtraction. So, is this, I don't know what I was trying to write there. Is this a monomial? No, because it's connected through addition. And that would be your reasoning. And the last recap question of the day would be, how do you simplify a question that looks like this? All right, the first thing we got to do put parentheses, because that's the order of operations. So this 2 on the outside means I have to distribute this to every exponent that's present. So let's take a look at the exponents present. This 9 doesn't, I don't see one, but I can make one a 1. This P doesn't have one, so I can make it also a 1. So I'm going to distribute that 2 to each one of those exponents. So 9 to the 1 times 2 power becomes 9 squared. P to the 1 times 2 power becomes P squared. Q to the 7 times 2 power becomes Q to the 14th. All of that is going to be multiplied times 9P. Uh-oh, my 9 looks a little weird. So what do you do with that? Here we go again. We have a 9 and a 9. When they have the same base, what do we do to the exponents? We add them. So this is 9 to the 2 plus 1 power. So that's 9 cubed. Up, there's some p's. P squared and p to the 1 power. This is p to the 2 plus 1 power. We're adding because they have the same base. And then q didn't have anybody to add to it. So this would be their final answer. Here's what I want you to do. All right. So in your books on page 360, I'm not going to show you how to do this because I want you guys to read. They have on here, express the area of the square as a monomial. This is on page 360. If we take a look at the actual square on page 360, I'm still kind of stalling so that y'all can get there. We see that one side of the square is 4AB and the other side of the square is 4AB. They gave us a formula that the area of a square is S squared. So that means you got to take 4AB and square it. Just as we said before, we distribute that exponent to each one of the exponents. That is 4 to the first. So that's 4 to the 1 times 2 power. So that's 4 squared. This is a to the 1 times 2 power. So that's a squared. And that's b to the 1 times 2 power. So that's b squared. So that becomes 16 a squared b squared. All right. So those are some questions that I want you to take a look at. Yep. I think that's it. All right. So I want you to do numbers. All right, for classwork, I want you to do page 361. And you're going to do numbers 1 through 13. One thing that I want to express to you is the area of a triangle. So if you don't remember from geometry what the area of a triangle is, I'm going to give you the area right now. So I suggest that you write this down. So to do 10 and 13, you're going to need this formula. That formula is area is equal to 1/2 the base times the height. 1/2 base times height. So you're going to do half of that times this times this. And it's not that bad because half of 2 is 1. And then you'll just multiply n squared times 5n squared. All right. So if you have any questions, feel free to email me. Here's my email address again. helpmsnelson@live.com. And you can also rewatch the video on my YouTube channel, which is Andreas Miguel. All right. Your homework is going to be the bottom half of this page. So if you finish early, please do the homework. And that'll be 14 through 30. All right, guys. Have a great day.